Modulation techniques means to overcome the drawbacks of a baseband transmission, which means the baseband consists of a very low frequency. Here we have a baseband signals by a radio, and the baseband is of a low frequency signal, which cannot travel a very long distance. Just like we need to transmit this signal for the longer distance, we need to send it as a stronger one. In order to make the weaker signal into a stronger one, we need a technique called as a modulation. How we define a modulation means, modulation is a process of superimposing a low frequency information signal on a high frequency carrier signal, which means we are sending the information in the form of a modulation. By using a modulation, why we need a modulation means we need to get a reliable operation, which means the receiver has to get a qualitative signal which has a which does not omit the message. So in order to have a reliable signal, we need to have a modulation. So how is the modulation done means, modulation is done by superimposing a low frequency information with a high frequency carrier signal. Okay, we can see that with the example. Here the information is like a man and the car is like a carrier. So we need to get into our destination. For the destination, for reaching of a destination, we need to use a carrier like a car. So in this we can get see the modulation in the form of a pictorial way. In the first signal, we are saying it as a modulating signal which is meant to be modulated, and the second one is a carrier signal. We can see the difference between the modulating signal and the carrier signal, which means modulating signal means the signal has to send, which carries our information, which has to be sent to the receiver side. So, and a carrier signal which consists of a high frequency, which means we can see the difference. In the modulating signal, it has a one cycle. In the carrier signal, it has multiple cycles, which means in order to send our information from one place to other place or over a long distance, we need to have a stronger strength in our signal. But if we are having a very low frequency signal, which is which is not liable to send. So we are using a carrier signal as a carrier, means which we need to send. We need some carrier, by what means we need to send our information. So in order to send our information, we need to have a carrier. We are using this high frequency signal as a carrier. So in the third waveform, we can see that we are superimposing with our low frequency signal with a high frequency signal. But we can see that a carrier signal consists of a number of signals. In a third picture also, we can see the number of cycles are same, and in the modulating signal we have some amplitude, and in a third waveform we can also see that the amplitude is same, which means we are not changing any information which is original. So we are only using our carrier signal as a carryover, and we are getting our original information, and we are passing to to reach our destination to the receiver. So we are using a carrier, a high frequency signal as a carrier, and we are sending it to the destination or receiver side. In this modulation techniques, we have majorly we have amplitude modulation and angle modulation, and in the angle modulation we have other two types. In it you can see that pictorially, like a modulating signal is like a information which is like a man, and as a car means a carrier, we need to send this man to a destination, which means information to the destination. So we are using a car as a carrier. And this why we need a modulation. Why we need means baseband signal transmission cannot be used for the radio communication. Radio communication, for the radio communication we need a modulation. Why we need a modulation means baseband signal cannot pass for the radio communication. To transmit the baseband signal for the radio communication, modulation has to be must. So what are the necessary conditions which made to have a modulation means, in order to reduce the height of an antenna, and avoid the mixing of signals and increase the range of a communication, and multiplexing is possible and improves the quality of a reception, which means if you are sending we are transmitting signal and we are receiving a signal. In this transmission transmission and receiving, we have some components which we need to receive. In this receiver side, we have antennas which receives the information which you are out to send. So when you are sending the information, we need to have an antenna. This antenna has to be high. If the signal is very low, this antenna has to be high. If the signal is strong, we can with the minimum height we can get the information as it is with a qualitative one. So in order to reduce the antenna height, why what makes the reduction of antenna means, if the antenna is high, it may causes a birds or a flight, other kind of complications will be there. So in order to reduce that complication, we need to have a reduction height of antennas. And next, avoiding of a mixing of a signals. Mixing of a signal means if you are sending same frequency signals in the air, they may lead to a mixing of a signals. We can get a noise like information which is not worthwhile. So in order to avoid this mixing of a signals, we need to have a modulation and increasing the range of a communication. By using a qualitative one, we can increase the range of a communication, and the multiplexing is possible. At a time we can send a different n number of informations at a time and improve the quality of reception, which means we can get the original signal which is ought to be sent to the receiver. And then in order to avoid the mixing of our signals, we need to send the signals at the different frequencies. At a different frequency. If we use the same frequency for every signal to transmit, they may lead to mixing of our signals. In order to avoid this mixing of our signals, we need to send the signals at a different frequencies. And this is the pictorial representation, which I earlier said that we need to send the signal at a different frequencies. Here in the first picture we can see that we are sending a baseband signal 1 with the frequency of a 3 MHz as with the carrier, and the second baseband signal with the 2 MHz as a carrier, and the third baseband signal with the 1 MHz. We are using different channels to transmit. Here we are avoiding the mixing of a signals for 3 different kinds of base signals. And here the classification of a modulation. In the modulation we have a analog modulation, distant modulation, which means analog modulation means it consists of a analog form of signals. In the distant modulation means it consists of a zeros and ones. And again the analog modulation is divided into amplitude modulation, angle modulation, and pulse analog modulation. And distant modulation, pulse code, delta. And again we have a classifications in analog modulation, angle, and pulse angle modulation. And basically here we are concentrating on amplitude modulation. And these are the types of modulation, important types of modulations like AM, FM, and PM, which means AM means amplitude modulation, FM means frequency modulation, and PM is a phase modulation. In the diagrams or figures of a second waveform section, we can see that the variant kinds of modulation techniques. We can pictorially see that. In the first amplitude modulation, we can see that amplitude is varying over there, and the frequency modulation, here the frequency is varying, and then the phase modulation, the phase is modulating. Here in the amplitude modulation, only amplitude varies, and the frequency and the phase are meant to kept a constant. And the frequency modulation, we are varying only a frequency, and we are meant to kept a amplitude and a phase as a constant, as earlier as the same of a phase modulation. In the phase modulation, we are varying the phase, but we are keeping a frequency and amplitude as a constant. And what is the definition for the amplitude modulation means? Amplitude modulation is a technique of modulation in which the instantaneous amplitude of a carrier signal varies in accordance with the amplitude of a modulating signal, while frequency and a phase of a carrier remains constant. The nature of amplitude modulation, we can see in the next slide. Here it is saying that amplitude modulation is a technique of modulation which is instantaneous amplitude of a carrier signal varies, which means the amplitude is varies, but the frequency and phase are meant to be constant. We can see it in a pictorial way. Here the first science shows that the amplitude of a modulating signal, which is information has to be sent, In the second, we can say that number of frequent cycles are high, which means a high frequency signal, which is acts as a carrier signal. And in the third waveform, we can see that the modulating signal and a carrier signal are superimposed. You can observe here as the amplitude of a modulated signal is same as of a amplitude modulated signal, and the frequency of a carrier signal is of a same as of a carrier signal. Carrier signal is same as of an amplitude modulating signal, which means we are carrying the same information with a high frequency. In a modulating signal, we have only one cycle, but in amplitude modulated signal, we have a higher frequency, and it consists of the same information as that of a modulating signal. This, how much of modulation is done, means we can know it by this modulation index. What is a modulation index means? It is defined as a ratio of amplitudes of a modulating signal to the carrier signal. Here the modulating index is given with a small m, and we can have a ratio as a em by ec. Here em is a modulating signal amplitude and the EC as a carrier signal amplitude. And we can also have a modulation index as m is equal to V max minus V minimum by V max plus V min.